So, yeah, I wanted to be a quick, give a quick update on the PlanetaryPy core library. And I apologize to my fellow member of the technical committee to not communicate more about this. Yeah, simply because my time is also very constrained, and whatever seconds I have, I fit into this library thing, and I will basically give you an update on where I think it is useful now, and yeah, and where we're standing. I want to give a start the technical committee that is semi-regularly meeting. Well, almost regularly, but I often have to push a week or so because something is going clashing with appointment. People are very, very appointment constraints. It's hard for us to find meetings with 3 institutes at the same time, and yeah, I think one can feel that lots of my collaborators also clashing. So, what is the PlanetaryPy project? Let me just do this in slideshow mode. Okay, can you see the slides? Thumbs up from Chase. It's still coming. Yeah, okay. I guess it takes a while. All right, so this is a few slides from our planetary data workshop summary. So we have a summary sentence here in our charter. This is a community effort to develop a core Python package for planetary science, but also foster interoperability between Python planetary science packages, and this is for existing and upcoming. So we loosely model ourselves after the open source projects like AstroPy and Node.js, mostly for the community items, because they have a lot of experience on how to organize the open source projects with the governing body and how to crystallize opinions out of discussions and different technical opinions, things like that. So we're doing the technical committee is all doing all the work in the open via a GitHub repository. We have a code of conduct, we have a charter, we have almost monthly open meetings. Everybody can join. I try to make an agenda up front, but Ross is helping me out with that very often. And then we try to send the link around in the PlanetaryPy channel on Slack. Yeah, and then we have meeting agendas and notes available on the website. Okay, I want to quickly remind people that we have affiliated packages. What that means is that they have gone through a review process for documentation, for scope, and for tests, and as for that the development is happening and what kind of Python version is that still relevant and things like that. So we have currently 3 fully accepted packages and 1 ongoing package. PVL is a very important PDS-free label reader. It can read, I think, all PDS labels that of the version 3, and plus some other magic stuff with from ISIS, which has its own dialects and things like that. SpicyPy, most people know that, a very widely used Python spice wrapper, recently released version 5 for the most recent update on the Spice toolkit. That was also being talked about here in this forum. Then we have Color Series, which I use very much now these days. It's a newer version of a wrapper around the ISIS commands, more Pythonic, Python 3 fully supported and ongoing development. And then we have Creator Studs. It's currently in development. We have communicated with the PI that we want to go on now with a review. He applied to be an affiliated package a while ago, but we wanted to have a bit more tests and things like that. And now it looks quite good. There's a lot of stuff was added, so we want to check if we can have that as an affiliated package now. So that's basically a Python version of a more widely distributed and used IDL code that maybe some people are aware of. Okay, a quick overview of an approximate design idea. What was PlanetaryPy core library about? Oh, I have an old text forgotten here from the PDA in the lower part, so ignore that paragraph in the lower part. But in the upper right, you see that we have a funded PDART related to this. Chase will develop a planetary data reader, and I put the in capital letters there because it's the planetary data reader we are hoping. We want to cover as much as possible. I'm a co-I on this, and once this is working and coming out of beta, or maybe in beta, we don't know yet, but at some point we want to have this as part of this journal core library. I think Chase agreed that this would be the most basically going for the low-hanging fruits of Planet constantly, and I have more about this in the next slides. So basically reading it into memory and getting it onto your drive in the first place. These days still it's useful to have it on your drive, even so that might change in the next 5 years. So to have this in this library, we think it's still useful. And as you can see here, the read box is not reinventing the wheels. It is combining what exists, solving problem cases, but otherwise combining what exists and just offering one API, one access to the data, so that the user doesn't need to know about differences between rasteria or planetary image, planetary input-output systems, or the old VCAR and things like that. But yeah, we don't want to reinvent everything. We just want to combine it in a way that new people don't need to learn all this underlying stuff, if it's only about getting the data into your memory. Okay, I'm working on the left part here, data access and the data manager a lot. So basically my vision about this is that newbies don't even need to know about PDS nodes, but they have read maybe a data ID in a paper, a Highrise image ID or something, and they should be able to type this into my tools, and then they get the data. They don't know where it is. It just comes down. If maybe with a warning, if it's several gigabyte size, then they could get preview images of this just to see if they actually want it. But most likely when they read it in the paper, they want it, right? And then, like I said, this library will provide you with the paths to the objects that you have downloaded, either label files or the data files itself. And yeah, I will talk a little bit about how far this would go in the next slides. But this is some kind of approximate design layout that I once put together for a presentation. Here in the lower left, you see that the PDS nodes would be wrapped in a way that when you have a data ID of a certain instrument, then it would automatically find on which PDS node this goes. We have a configuration file, and that's something we also could have collaborators help us to fill up that file with paths to PDS things of data that people want to download. That's a very easy way to collaborate. Okay. Yeah, so a few more words on the approach of this core module. So I'm really aiming for the low-hanging fruits here. I have this vision for a long time that specification in terms of science tasks is far too branchy. It's like many tasks are very specific to a certain science question. However, there's a lot of annoying tasks that come first, that are everyday tasks. You need to do them every time you deal with any data. It's like, where did I save the label now? Where's that? Did I save a second processed version of that data file already in that folder or not? These kind of things I want to manage for you if you support this idea. Of course, I also support the idea that you just download things into a current folder. And if you just don't want to trust an archiving system and you just want it now, where you are currently, then you can also do. I'm developing a storage system that is, I like to call it sometimes the Apple iPhotos for planetary data. It's just, you don't care where it is. You give it an ID and you get the data out. And if it's not there, it even can automatically download it for you. And if it's there, then you just get it from your hard drive. So questions of like I post here appear very often. You have times somewhere in a table, but they're in strings, but you can't plot them because matplotlib would like some kind of date time and things like that. Or they have a funny date number in there from NASA missions they use on PBS. They use this 3-digit date time number. And AstroPy Times, interestingly, still doesn't support that. Maybe we should put a PR in there that they do, but I wrote a small converter for that so that you can use, that you can easily convert the whole content of a table of these times. Yeah, where is my data? It's a normal question, but I see people copy and pasting the paths to some kind of file where they stored it, and for different missions is at different locations, right? So people need to develop their own system. And my idea is that this library comes with a system. You don't need to develop a system. It's sorted by missions and by instruments and by data levels. And then you have the data there. You can always find where it is, but you don't need to care or design it for yourself. And then a recent addition I put is spice kernels. It's like, for this date of this year, what spice kernels do I need? That is a very often asked question. And the Spice website has a subset system where you can manually put in your stuff, your dates, and then you get the spice kernels out and you get a meta kernel for that spice kernels to load. But you always need to edit that meta kernel because the paths are never correct for where you put the data. So it's always some fiddling with that. And I am very happy to say that I wrote a wrapper around that always will create the correct meta kernel for you wherever you decided to store the spice kernels with my tool. So that's kind of a neat thing. I'm very happy about that. Yeah, so the current thinking, but I want to discuss this further with my fellow TC members, is that science-specific tasks go into an affiliated package. So we would have a sub-package that focuses on maybe a special Highrise driver or a UVis, Cassini UVis package that does, plotting that depends on the data formats. So depending on what kind of data you have in different dimensions or times or wavelengths and so on, this can be very specific. So I don't think currently, feeling-wise, that has space in a very low-hanging fruit core library. It would be an affiliated package that then gets the data paths from the core library to manage things. That's at least my current thinking. But of course, this all can be discussed. All right, so development status, just a quick summary before we do some demos. I have, as I said, for several years, I have a specific vision for this to be just very simple, but helping you with this everyday nuisance tasks. So we in the technical committee, we first had the idea to develop this from scratch, but it was very time intensive, also too time intensive for me to be motivated to start from scratch. So I just, at some point, I just ran away and said, okay, I have already so many tools, I glue them together. So I will develop a core candidate, and I'm developing that alone at the moment, which is fine, because then we can discuss still later. Everything is changeable. Now, thanks to Git, we can cut things out, we can put them somewhere else. So it's really not too bad, but I want to be in a certain state where I then present it to my TC members. And I didn't even tell them yet, but I think we should not even enter it. I think I should apply for it to become core, and then you guys will review it, and other people who maybe were better users are also could join the review. That's a nice thing as well. So that's why I'm asking for beta users now, somebody who's maybe not scared of imperfect software, who could try out my tools and then think what they see, create GitHub issues on what's wrong with it or what features still could be added. And then when we think it's far enough, then I basically will apply for this to become the core library, because currently I develop it in my own regime. And this, like for the affiliated packages, this core library would be then having a review of the scope, how far does it go, of tests, and of the documentation status. And I have a slide about that as well. So it would go through all the same reviews that anybody else who wants to create an affiliated packages would do. And I think that would be a quite fair process, and it's not something then that we just simply or I just simply decide that's the best. And then my colleagues, they already make good suggestions, for example, to not force the users into a buy-in into the archiving system if they don't want to. That was a good suggestion by Ross. Or Benoit suggested that my time utilities would not, have the user to think about if it's a date or a time, but just automatically does both. So that was a good suggestion as well. I've implemented that. So I think we are quite critical towards each other, but also fair in terms of being productive with our few spare time we have, as we're not getting paid for that. I mean, some tasks are being paid for it, but this specific task is not being paid for. Okay, documentation efforts. I'm a big fan of this. I don't know who came up with this idea, but there's this idea that good documentation has 4 main pillars for technical stuff. It has tutorials, how-to guides, explanation, and reference. And the doc status of what I have is currently not too bad, thanks to the NBDev environment that I'm using for developing this whole package, but it's a bit technical because it shows notebook will also go to the documentation as well. And then I will write some tutorials and how-to guides. Tutorials, as they say here, are learning oriented, where actually a new planetary data user could learn. Maybe I will write a little bit from a section I wrote recently for a book about what is PDS data. And I will add this to this tutorial and saying, okay, we have different processing levels and things like that. And with this tool, you can either get that level or that level. So that would be a tutorial. And a how-to guide would be a very specific thing, like where I would put in, you need spice kernels for this instrument for this date. How do you do? And that will be very short and to the point guide. And then explanation will be a little bit of also of the data levels, what exists, the reader problematic, that the formats are also different, and maybe design philosophy of this package, and where other tools come in. So yeah, so this is where I'm aiming for the documentation. I think this is a very nice system where everybody gets something out of it. Like it says here on this graphic, most useful when you're studying or when you're working and things like that. So, by the way, this is a documentation tool I found just by looking for this graphic on devio.com. They are selling some kind of documentation tool. It looked interesting, but we have a quite nice tool with NBDev and a Jupyter Book now, where I think we can make very appealing documentation online ourselves without paying any money. Okay. How can you get it involved? If you have a Planetary Python package or some scripts, you can submit them. I forgot to add that here. We actually have a repository on GitHub that's called Scriptorium, where I just also uploaded some, and Ross uploaded some, where I put some rough status spice calculation tools. So I want to add that to the core library as well. It's a very basic illumination calculator for all major planetary bodies. So if the spice toolset has a number for that body, and it's not a complex shape, then my tool already should work in a way that you can just calculate for a given date and time. You can calculate the illumination angles. And that's a very often useful task if you just want to think about the physics that's happening on the surface of a body. And it's just wrapping the cryptic C function names that we inherit from the SpicyPy, who's wrapping the C library, and obviously to be a system conform to the original C library, we didn't change the function of the spice calls. So that's sometimes a bit hard for a newbie, which is why I thought a wrapper a few years ago. I wrote this wrapper also for myself, so that I didn't have to remember what needs to be, which function name goes where. Yeah, so I'm asking for beta users. So please come and send me the tests or some lines that break. Bugs is always good to find, because that would uncover some things that are not working, and maybe uncover some design issues, some layout issues that I didn't think about. And you could also feel free to come join us in the TC meetings that are every third Tuesday by default at 1:30 Mountain, I think. Yes, so that there's a half an hour between the op lunch, the virtual lunch, for having some food yourself if you didn't have time before. Okay, demo time. I'm stopping this presentation. If there's any questions now, I could answer some questions. Otherwise, I could start some demonstration. Okay, kernel. Let's see if they're working or not. So they might fail, but I hope they don't. Let's see. So let's start, like I said, with the low-hanging fruits, times. So I have from PlanetaryPy, there's a utils module. So the question I pose here, do you remember the string conversion code for day of the year? At least for the longest time, I never could, and that's percentage %J. J is the time string conversion code. And for me, this utility is worth it, even so it's very simple to use the date-time string conversion tools. But for somebody common in planetary science to make them go through the Python documentation, first find out that it's daytime that is doing these things, then find out the string conversion code and so on for the day of the year, I think it's worth to have a utility that just converts these PDS date time codes that have times like this. Oh, by the way, should I increase the font size? What do you people think? Is it a bit small?
If you can make it a little bigger, I think that'd be good.
Okay. Like that? That enough? Maybe I'll make one more. Okay. Okay, so times like this, sorry, times like this, so 2002-137, that's the day of the year, or very often, so either that, or you have the full time code in it, time data. So just really deal with sequences on its own. Currently, but in Pan, as I mentioned, convert as if this tool also could deal with a list of times automatically currently. So that's something I already took note of. Anyhow, so this is compiling without hours. You also only get hours. Sorry, you get the date without hours back. You get a date. Or you come in with hours, okay, and backwards goes the same way. Sometimes you need to do the other way around because maybe a website wants the day as the day number, or some other old table, you know, that you didn't convert it yet. You need the other way around. I think both ways around is quite useful to have. Funny network things. Check that an URL exists. This is sometimes useful if you have thought you created an URL correctly for PDS or something like that, and you want to check if it exists or not. This is I think it was this one. Let me check. This is using some code I found. Overflow. No, I'm happy because overflow ended. Discussion. What's just check if you have And that's kind of sometimes useful if you write a tool that needs internet and you just because you don't have internet, then you could write an if statement to use that. And then of course I have a down is as well. So and a notebook. So this is downloading some slides, some PDF from my website. So this is pretty handy just for some general things. Okay, then the next important PDS websites and use their search engines, but I still find it useful to get index files on my own, because then I have a whole catalog of what data exists on my hard drive, and I can travel and dig through the data on my own terms. Maybe I'm liking pandas more than the website interface or things like that. So you could get index like that. And the way this works is that first, what indexes exist, you can check like this: find index cassini.uvis. So I came up with basically a dot-based mini language. Oh, it's just an identifier really separated by a dot, where you have mission.instrument.indexName. And the index name you get with find indexes. And then with get index, you get that index. And if you don't have it yet, you can download it. I mean, this tool will download it for you. Because I have this index already, it's just giving me the pandas data frame. And what happens in the background is that this PDS table, that's a text Pacquiao file these days. HDF is having increasingly issues with data types of modern data types that the pandas system has introduced. So that's why I went to Pacquiao, and it's also more modern and ready to work on the cloud as well. So Pacquiao is a good and fast and very highly compressing choice for bigger indexes as well. Yeah, so you just type in a get index with a dot separation, and then you get the index file, and you have a nice pandas data frame. And yeah, here's a few more examples. Cassini ISS, there's these index available from and these come from the Ring Moon systems node. And you get the indexes like that. And then we have some indexes that are not having a specific location for the cumulative index for the whole mission. But because the mission is still ongoing, they have these volume deliveries. And every time you need to look up what's the last volume and then find the cumulative index from there. So I wrote a web scraper that is doing that for you. So basically it will find the most recent one. And by the way, the get index will also check every time you do get index, it will check, is there a new one? So you wouldn't be out in the rain if you have an older index and MRO already released several new volumes and you didn't notice. The get index will check the website and will download the new one in case you don't have it. So in this case, there was no new one, I think. I hope at least. So I have this, this is the CTX index, as I said, MRO CTX. And yeah, this is a second way, if you have a reason to separate it. That was an old API that I didn't want to kill in case somebody was already using it. You can use either MRO CTX and then the index name, or you can put it as one string as I used above here. So both is working. So that, yeah, everybody should be able to work with that. Then I have find instruments, just to check what instruments are supported. In this ETX for LRO, I have Diviner, Lola, and LROC, and I think that's are the supported instruments at the moment. And basically how this works is that I have a text file where the paths to the PDF stuff is in there. And this is only for the index files. For the data files, I of course need still some kind of tool set to work with this now. And I will show you an example for this as well. And there, I'm not as far as this. I don't have all of these instruments yet fully as an instrument interface for the specific data. But I'm still brainstorming about this. How do I do this so generic that actually maybe the index already will create this automatically an interface for the data itself? And I think that's possible, but I haven't wrapped my brain around that yet. So how this works. So I have hand implemented several data interfaces for instruments. So for example, here for the UVIS, I have a data manager, PlanetaryPy UVIS data manager. So for example, if I get myself an index to get product IDs, and that's of course an issue for newcomers. That could be in a tutorial for UVIS data. What is a product ID for UVIS? And every mission is defining that differently, unfortunately. So for UVIS, it is this last part of the string, the EUV and the year and the day number and then hours and minutes. That's the product ID in terms of the PDS nomenclature for UVIS. So how does it work now? I put already one here. So let me take a different one just to show you that it works. I copy this one over. Oops, sorry, there's like that. Copy this in here. So I do like that. And when I do this, it would either find it on the hard drive or download it like you see here. And all associated data with it as well. It gets the label, but I haven't applied for it yet. I have an affiliate package that I intend to submit as well for UVIS that does a lot of this stuff like operation for you. And by the way, I'm a PI of a PDA project that will create a new UVIS data product. So in that case, it will all be pre-calibrated and you don't have to calibrate it anymore. So that will be also good. But yeah, that's not part of this talk. Yeah, but what does this data manager do now? So it gives you these paths. So that you don't need to take care on where is it stored now. But of course, you might be interested in it. You want to know, right? So this is here. This is how it shows you where the data is stored. It's stored in my big drive under planetary data, missions, Cassini, UVIS, and the product ID, and then the specific file. That's for the label. That's for the raw data path. And that's the raw label path. So this before that was the calib label path for the calibration, right? Yeah, and then for example, for Highrise, there's so many products out there. You know, it's like no map and RGB and the original red one and the color channel one. For that, I created a product pathfinder. So if you put this product pathfinder here, you can import it from the Highrise web page, from the Highrise module of my tool. You put the product pathfinder in here, and then it gives you this local label path. It was already downloaded before, but there's also an A-browse path. Sorry, that would be the local path. I haven't stored it yet. So, but this is basically the way it would be stored. I actually stored it. Sorry, I have to remember that mention this. Here, this is how it is stored on PDS. And I was thinking, this is born out of file number restrictions per folder when I started the project. So I make life easier. I store all associated files into the Highrise folder with the observation ID, and they will be all inside here. So they don't mirror the precise structure of PDS on our drive. If somebody needs that, I think Ross has tools like that. I'm not sure if he published them or not. Maybe they're available as well. But I think Ross is more closely, because he's a team member, he's more closely mirroring what's happening there also with the calibration. But I just want to make it easier for people then who want to have a look at that Highrise folder. So I'm cutting off this orbit management clutch and just put it into the Highrise ops ID. Other funny tools here, each ops observation ID of the Highrise image has a web page on the University of Arizona, right? So I made a little tool that for this product can go to the homepage, and as you can see, it's loading the homepage of University of Arizona for this data product. I'm guessing my internet is being used up by our meeting and so on. Things are loading very slow today, but maybe it's also lunch break. So let me go back to the demo. But anyhow, you can see here the URL. Here's coming. It's coming. Very slow loading. But basically that, yeah, that's kind of a funny thing. You can also only have the URL in case you're interested in that. And here, for example, is one of the the non-map projected JPEG2 product. It has a URL. You can find it like that, but you can also download it. For that, I have, if you do from, before I go to the spice kernels, let me just show you one more here. I have a detailed product management thing for more functions, and that I'm not so sure it should stay in core, because I'm thinking this already becomes too specific. An RGB no map data manager. So that one does some of the specific plotting and data management. Yeah. So don't forget that when with a dot and pressing tab, you always get an overview of what an object can do for you. See here I can download it, the item. Yeah, so this is the conceptual differentiation I need to do. For indexing, that's not the data. Indexing downloads the index, but each data at the moment has a different data manager that downloads the data, right? So it's hard to make that universal, but this is something that we can discuss what people think better, and then that's something in the progress we still need to discuss in the technical committee meeting. But here you can see what's being offered. You have a local path, you have the offset, and you can plot actually a Highrise data product using using data shading technology. And the cool thing is, even so the Highrise is big, actually, I think I have this in my database. I'll just quickly check this. In recent changes, I worked a lot on the Highrise module there, and yeah, so then it is stored there. Yeah, and the plot actually works as well, but I think I renamed something wrongly, so I apologize for that. But I have a lot of development ongoing. If you go to my website, you see the change notes as well. I create change notes based on GitHub issues, so that's working well. And now I wanted to show you the spice kernels. Where do I have them?
Michael, there is a question in chat from Christian. I don't know.
Okay.
Does each instrument from each mission need its own data manager to be implemented before we can use it? Or are there some routines shared across all of PDS?
So shared from the PDS, of course, you will know there is nothing. So, and yes, that's what I slightly alluded to. I think there is a way I can design it where some basic data manager should be available simply because an index manager exists. But I haven't read, as I said, I haven't wrapped my brain around that yet. But I think that's generalizable in a way so that all the indexes that are supported, you should have a data manager. And if I just need to do the imports correctly so that people can always write from PlanetaryPy.Highrise or from planetary.Cassini.Cassini-ISS import data manager, so that that data manager does the correct thing, right? And that generalization, I haven't gotten around yet so that it's working. I implemented by hand some of the data managers But yeah, that's still to come. But I hope I'm getting around this in the next few weeks, that that this is generalizable. That would be very powerful, because then we can just add the index directions and where the data is stored on PDS. And because I always store it systematically by the mission name, it should be generalizable in a way that the data manager does that always correctly, right? So yeah, as I said, maybe you should come in and join the meeting, and we could brainstorm on how could that be in the architecture of the package. Okay, just a quick demo on the Spice kernels, because that's pretty neat. I have not written a clean one, but here, this is the list basically on the same. This is the archived Spice kernel websites. Sorry, the archived Spice kernels datasets from Knife at JPL. So these are all the missions that are supported, and this PDS, this pandas table, you can get this if you type this from PlanetaryPy Spice kernels, spice.kernels import datasets. Then you get this pandas dataset, and it gives you the start and stop time on where Knife is supporting this automatic downloading of the correct meta kernels per date. So it's pretty neat. I have implemented these shorthands for any code that you write where you want to use it, with a full mission name here. And you could use this table basically to have a nice plot. If you make automatic plots or something, you could maybe use this table. But these are basically the paths on where this is stored on Knife. And then my tool is wrapping basically this script. It's checking if your start and stop time is valid. So if you can see here, this code, the Cassini times, the 98 is true, is valid, but 97 is too early. Is therefore the start valid is false. So if you come in with the wrong time, the tool will tell you. Okay, this is a subset, and it's just the code. Here's an example. I put in subsetter Cassini for year 2014 on the day number 270. And the day number is because the data, if you find Cassini data in the label, they actually use the day number. That's what I meant before. Sometimes you use this day number, but then again, if you or UTC. Okay, this just went online and used the website interface. And now it has identified these kernels to be available and downloadable from this website. Maybe in this case, it already has them. Yeah, this is just a test. So excuse the code heaviness here. I need to put this into a demo mode more. But here, if you do, for example, subsetter Cassini start and end date, by the way, if you leave out the end date, it just assumes one day. So that's also handy. So, and then you get a URL. This is how it works, actually. This subset system gives you a URL file with all the URLs, and my code is going through this file and downloading everything. And here's the meta kernel file. So it creates a meta kernel file, and then my tool goes into that meta kernel file, corrects the path on where you store the files with the download I'll show you in a second. Okay, but if you only want the URLs and you want to do it yourself, you can do like this. So here's all the URLs, and they're actually clickable in the notebook, and you could go there yourself if you so want to. But then get local path for one of these kernels. Basically, this is where it's stored now here on my big drive in the Spice kernels section, mission specific. And you have to do that because these naming schemes are not protected. So a mission could accidentally have the same name, like a different mission, therefore they need to be sorted, even so that might duplicate some data. Save location. So if I just want to save them here, then I force them to locate them just like in this local directory, and don't use my archive system. You can do that. And but if I reset it to none, then I can download the kernels. Here it just checked what is to download, and then it said actually everything is available, so I don't need to download everything. And that's it, I think. Get the meta kernel, of course. So if you get the meta kernel, this is a path to the meta kernel file. And this is how it looks, the meta kernel that was storing it. This means that you can directly use this now and load it. And this is a spice furnish command. It just loaded that meta kernel with these kernels that were downloaded by my tool. So I think this is quite handy. All right. I think that's it I want to say. And we have a few minutes left for questions.